Ever tried to schedule a meeting with 10 people across different departments? You open the calendar view, but half the calendars are empty or out of date. Then you start sending messages. Are you free Thursday at 2? What about Friday at 3? Some people reply right away, some reply hours later, and some answer with fuzzy availability like Thursday afternoon works, except from 2 to 3. The real problem is not just finding a blank space on a calendar. Group scheduling is broken because calendars are incomplete. Chat coordination is manual, and the person organizing the meeting has to translate all those messy signals into one final meeting time. If we break the task down, scheduling is actually a very repeatable workflow. First, the organizer names the invitees in the rough candidate window, for example next Thursday or Friday afternoon. Second, the system checks calendar data where it exists. Third, for missing or unreliable data, it asks each person through their preferred channel. Fourth, it parses the replies, including natural language replies like anytime except lunch. Fifth, it compares all constraints and proposes the optimal slot. Finally, it books the meeting and sends the invite. My insight is that the agent should not ask everyone everything. It should predict availability first, then ask only where confidence is low. The key product shift is moving from polling everyone to resolving uncertainty. In the old way, the organizer checks calendars, sends manual messages, waits, and then reconciles contradictions. In the agent way, the system builds an availability model from 3 types of signals: calendar-free busy information, chat replies, and historical patterns. For example, if someone is almost always unavailable on Tuesday mornings, the agent can treat that as a low probability slot even if their calendar is empty, but it should never pretend to know everything. If the confidence score is low, the agent asks a quick clarification. That keeps the user in control while still removing most of the coordination burden. From the user's perspective, the interface should stay extremely simple. They should be able to type a natural language request, such as, schedule a 30-minute check-in with Alice, Bob, and Carol next Thursday or Friday afternoon. The agent then does the coordination in the background. It can return a candidate time, show who is confirmed, show whose reply was parsed, and identify who still needs clarification. In this example, Alice is confirmed by calendar, Bob replied that he is free except lunch, and Carol still needs to be asked. The user does not need to manage the whole conversation. They just review the proposed slot and decide whether the agent should ask Carol or book a tentative hold. For the AI user experience, I would focus on 3 design considerations. First, inputs and feedback loops. The agent takes natural language instructions, time zones, must avoid slots, and optional priorities. If the organizer overrides the suggestion, that correction becomes a preference signal for the future. Second, transparency. Users should be able to click why this time, and see the evidence, such as Alice has a calendar event from 2 to 3, Bob replied free except lunch, and Carol has no reliable signal yet. Third, communicating uncertainty. The agent should use clear confidence states: high confidence when the calendars and replies agree, medium confidence when some prediction is involved, and low confidence when human clarification is required. Privacy has to be designed into the product from the beginning, because the agent touches sensitive signals. Calendar entries can reveal event titles, attendees, locations, and personal routines. Chat replies can reveal availability patterns and even sensitive inferences, such as regular medical appointments or caregiving responsibilities. So the default should be data minimization. Read free busy information unless the user explicitly allows event title access. Consent should be granular, meaning free busy access is separate from chat access and separate from event details. The system should retain scheduling data only as long as needed, encrypt connector tokens, and provide a dashboard where users can revoke access or delete their data. This aligns with GDPR expectations around consent and deletion, CCPA expectations around data rights, and workplace expectations around clear notice. There are also important ethical risks. One is reply bias. The agent might give too much influence to people who reply quickly in chat. Another is calendar culture bias. Some senior roles keep very full calendars, while junior staff may have emptier calendars, so the agent could unfairly assume junior people are always flexible. A third risk is language bias. If the model is mostly trained on English scheduling phrases, it may misunderstand non-English or informal replies. The mitigations are concrete. Constraint weights should be equal unless the organizer explicitly prioritizes someone. Scheduling decisions should be logged so the system can explain why a time was chosen, and the model should be audited across roles, time zones, and languages to make sure one group is not consistently assigned inconvenient meeting times. The same core machine learning problem applies far beyond office meetings. A family reunion may involve 10 relatives in different time zones using different calendars and messaging apps. A university study group may coordinate through group chat and informal replies. A nonprofit may need to schedule volunteers who do not keep detailed calendars. A doctor's office may need to coordinate appointment reminders for a group. In all of these cases, the challenge is the same. Predict availability from sparse signals, ask clarifying questions when confidence is low, and optimize the final meeting time under constraints. That is why I see this as a cross-platform scheduling copilot, not just an Outlook helper. Any calendar, any chat channel, fuzzy natural language availability, and a transparent agent that gets the meeting booked.